Successfully start, sir.
Yes, sir, we can start, sir.
Yes, sir. Yes, sir. Thank you, sir. Good afternoon, everyone. On behalf of the management, Dr. Mohanli Pandit, Director, Academic Staff College, Dr. K. Gomadi, Dean, Academic Staff College. I warmly welcome our distinguished speaker and participants to today's session. Once again, I welcome you all. Without further delay, I hand over to you, sir. Thank you.
Thank you, sir. Dear participants, go for the next session. Sorry for the inconvenience. Let's start the next topics of the analysis in JAMOVI. So the morning session we have shown about these topics: hypothesis testing, that is parity test, unparity test, simple parity test, simple t-test, and parity test. So these are the tests we have shown in morning. Once again, I'm going to share my screen. So today morning we have seen about the t-tests. So what is t-test? What are types of t-test? Simple t-test. All the t-tests we have seen. So now we are going to see about the topics of linear regression and analysis of variance. So now we are going to see about this analysis of variance. That is, here we have this ANOVA. The third option is ANOVA. We are going to see about what is ANOVA, and regression. Here the topics we are going to cover in the next 1 hour.
Sir, you are not audible, sir.
Yes, sir. Yes, sir. I'm going to start, sir. 1 second, sir. Okay. We are going to see about the analysis of variance. One-way ANOVA, that is using, we have two types of ANOVA, one-way ANOVA and two-way ANOVA. So now we are going to see about this analysis of variance, that is one-way ANOVA. That is, which will be available in the third option of JAMOVI ANOVA. So what is the analysis of variance? That is, the ANOVA is nothing but the first two letters of A in analysis of variance. That is, analysis of variance is called as ANOVA. It's a procedure for testing the difference among different groups of data for homogeneity. So we have different groups. From these groups, we have to check that X bar it's represented as inferential statistics is a X bar and descriptive statistics is a new value. The technique is called as analysis of variance rather than the analysis of means. Instead of analysis of means, we are saying it is analysis of variance. Sorry, am I audible? Hello, sir.
Yes, sir, you are audible, sir.
Okay, sir. Okay, sir. Thanks. Actually, it was disconnected. That's why I'm checking. Okay, sir.
Okay, sir. Okay, sir.
The technique is called analysis of variance rather than the analysis of means because the difference between the group means are compared by analysis difference between the group variances. So ANOVA is a separation of variance ascribable to one group of causes from the variance ascribable to another group of causes. So it is described by Professor Ronald Fisher. So total amount of variation in a set of data is broken into two types: variation due to specific cause, variation due to chance. So variance due to specific cause is nothing but that is can be detected and can be controlled. That is variance due to big specific causes. Variance due to chance means beyond the control of human hand and cannot be traced separately. That is called as two types of amount of variation: variation due to specific causes and variation due to chance. For example, we are going to do the ANOVA. We have the table of compared the three experimental batches with the following results. Each point is the time in minutes for 50% of the solution for a single tablet. Okay. So there is a tablet, they're going to check on a tablet. The tablet is compared for the three experimental batches with the following result: the batch 1, batch 2, batch 3. When the batch 1, the tablet is dissolution, 50% of tablet is dissoluted in the minutes, 15 minutes, 18 minutes, 19 minutes, 21, 23, and 26. The batch 2, 17, 18, 24, 20. Batch 3, 13, 10, 16, 11, and 9. So what is the research question? Is there a significant difference among the batches with respect of 50% dissolution time? I told you, the analysis of variances is nothing, but we have to check that homogeneity between the different groups, among the different groups. Okay. Is there a significant difference among the batches with respect to that 50% dissolution time? If there is a difference is there or not there, we are going to do that by using an analysis of variance. So how many variables are there? It has two variables. What are the variables? 50% of dissolution time for the tablet. The second one is batch. So these are the two variables we have. That is, we have two variables. They are 50% of dissolution time for a tablet and batch. So what are the type of variable? First one is the dissolution time. Second one is batch. So dissolution time is continuous, that is scalar variable. Then batch is categorical, that is nominal. Maybe batch 1, batch 2, and batch 3, that is categorical, batch 3. Next, which variable is dependent and which variable independent? So 50% of dissolution time is dependent. Based on the time, the tablet dissolution will be varies. So batch is independent. So one batch is does not independent to the another batch that is independent. So time is dependent for because all the batches, the time is common. That's why time is a dependent. So for example, this is take independent variable. Independent variable is what is that? Batch 1, batch 2, and batch 3. So each dissolution time of the tablet for the batch 1 test, batch 2 test, and batch 3 test. The dependent variable is the time, the resolution time of the tablet, that is 50% resolution time of the tablets. Okay. Next, we are going to do that analysis of variance by using JAMOVI. I will demonstrate. The basic principles of analysis of variances is to test for the difference among the means of populations by examining the amount of variation which each of the samples corresponding to the amount of variation between the samples. That is principles of ANOVA. The total variation can be between variation and within the variation. Between variation means a variation due to assignable causes. Within the variation means variation due to chance causes. Variation due to specific cause, then variation due to chance. These are the two types. So we are going to do that demonstration about the this tablet dissolution time between the different batches. We have to say that whether it is a mean difference will be there or not. We are going to tell about by using analysis of variance. So we are going to see a one-way ANOVA. So one-way ANOVA is used to examine the difference between the means of more than two independent samples. So if you have more than two independent samples, you can go with one-way ANOVA. It is used when we have a categorical independent variable. Yes, we have a categorical independent variable in this example. Batch is a categorical independent variable. A normally distributed interval. We have to check this the interval is whether it is normally dependent or not. The objective is to test the difference between means of the dependent variable and various levels of independent variables. So one-way ANOVA is the extension of independent sample t-test. So one-way ANOVA has one dependent variable, one independent variable. So in our example, we have one dependent variable that is 50% dissolution time, that is continuous. One independent variable that is the category of batches, batch 1, batch 2, and batch 3. That is, it is more than two levels. So one dependent and one independent. Similarly, what we have to do this hypothesis testing. Here also we have to follow the testing procedure. First, we have to set this our null hypothesis at 0. mu1 equal to mu2 equal to till mu k. There is more than one samples. I said that. Simple t-test, two sample t-test, more than t-test means we can go with ANOVA. Okay. In the last session, I told in designing the test, I show the table. The table I have mentioned. Now, how we have to decide the test. So we have more than one variables, mean variables. That's why I go with ANOVA. So the next H1 is alternative hypothesis. At least one pair differs significantly. That is effect of independent variable on dependent variable. That is where summation of I equal to mu I minus mu. So calculation of one-way ANOVA will be the maybe groups, errors, and tables. That is a total. This is the table represents the calculations. So it has a different calculation, that is statistical terms, p-values, f-test, MSS, and SSG. We have to do the tests. So calculation of one-way ANOVA, the total variation equal to variation between the groups plus variation within the groups. That is total SS is SS due to groups, SS due to error. So that is DSS is equal to SS groups plus SSE, SS due to errors. Okay. So this is that formula representation of one-way ANOVA, where Y bar means within the each group, means of mean within the each group. That is categorical variable. Grand mean the all observation Y bar. K equal to number of groups. N equal to summation of I equal to N to N. 1 to N, the total number of observations. For example, if you take 100 number of observation, hard study data we have seen in the yesterday hard study data we have examined, for N equal to 100. So here number of groups for this example, we have 3 batches, batch 1, batch 2, batch 3, that's 3 groups, that is K is 3. So grand means is total mean, a mean within the each group. So Y bar of J is batch 1 mean, batch 2 mean, batch 3 mean. Y bar is total batches mean value, that is total observation of mean values. So p-value approaches obtain the p-value from the FOPS as p greater than p of f greater than FOPS. So if p-value is greater than alpha, we have to fail to reject the null hypothesis. That is, we have to accept the hypothesis. That is, alpha is nothing but the 0.05. P-value is less than or equal to 0.05 means we have to reject the null hypothesis. The same procedure we should follow decisions. So your FOPS will be occur here, this at the F of observation, that is the p-value, that is a proportion value. So example, one-way ANOVA using JAMOVI. We'll see this example. So dissolution of tablet is compared for the three experiment batches with the following results. That is, it has a batch 1, batch 2, and batch 3. Is there a significant difference among the batches? Which batch is different? We have to give the solution for this question. Okay, we have that the data set is dissolution.csv. So the same procedure we have to follow. Open that JAMOVI file, open the menu, open this data set. What is the dissolution.csv file? It has the time and batches. So see here, the time of dissolution time of 50% dissolution time of the tablet. The batches batch 1, batch 2, batch 3 data are displayed here. Okay, first we have to set that time is a scalar variable. We change this data variable as time is a scalar variable, continuous, it is an integer. Then batch is categorical, it's nominal. We set the levels batch 1, batch 2, and batch 3. Now we'll go to that, check the normality of the data sets of the variable time, dissolution time. We got to describe the normal distribution. Next, we'll go with the analysis tab and click exploration with the descriptives and drag and drop the variable of what is the time and batches to the right side of the variable section and sort by section. And to get now, we have to give for that normality by Scapio, Wilk, and distribution skewness processes we can check. Then if it is normally distributed, you can get a plots. To get more plots, you can go with. Now we can go for the hypothesis part. First, we have to set the mu1 as mean. Mu1 will be to the mean distribution of the batch 1. Mu2 will be to the mean distribution of the batch 2. Mu3 will be the mean distribution of the mean distribution time for the batch 3. So mu1, mu2, mu3. So if I has to null hypothesis high, h0 equal to mu1 equal to mu2 equal to mu3. Alternative hypothesis means mu1 not equal to mu2, mu2 not equal to mu3. That is for at least one pair. If for any one pair, it will be not equal. Okay. Mu I not equal to mu j for H1. So mu1 is the mean dissolution time for the batch 1. So now go with the analysis part. Click on analysis tab, click on ANOVA, click on one-way ANOVA. Then here drag and drop these values here. Time and batch. Time is the dependent variable and batch is a categorical variable, that is independent variable. One-way ANOVA. Now I'm clicking that one-way ANOVA. I am entered and selecting the don't assume equal, that is belts, and execute causes analysis by analysis. We'll have a p-value 0.0005. It's not greater than 0. It is less than 0.05. Then we have to check Fisher's test assumes equal. That Wells means the don't assume equal. The means of variance does not equal means you can go with Wells. If it is equal means Fisher's. We check the p-values. Both p-values are less than 0.05. So Welker's ANOVA used to data violates the assumption of homogeneity of variance when the variants are unequal. Fisher's ANOVA means used when the data satisfy the assumption of homogeneity of variance, that is when the variances are equal. What is the p-value now? For Wells, already in the sound hypothesis testing, your variances is not equal means you can go with Wells test. Or else is shown in, for example, test V students test. Here Fisher's test, so 0.002, 0.005, both are less than, what is that, less than or equal to 0.05. So this is that one-way ANOVA. Select the descriptive table and select the descriptive plots. We can draw the diagram and plots for everything. So this is the additional statistics. If you want to do that additional statistics, you can do. You can plot that all the batches. So this batch ranges describes in the mean values is batch 1, this is batch 2, this is batch 3. Okay. So main thing is whether the difference is there. For that we can check the p-value. So assumption checks. So for the assumption checks, testing the homogeneity of the variance, select the homogeneity test, the assumption checks. So first variance H0 is variances dissolution time, the 3 batches are equal. H1 says variances in dissolution time for the 3 batches are not equal. That is, null hypothesis H0 is equal, alternative hypothesis is not equal. So homogeneity test, we have to go for Levin's test and Borlaug's test. Here the p-value is 0.6, 0.7. It is greater than 0.05. Now Levin's test decision, the f-value is 0. That is a statistical value is 0.37346 is associated with the p-value, which is less than 0.05. We fail to reject the hypothesis. It is not greater than 0.05. It is greater than 0.05. It is failed to reject the null hypothesis. Means we have to accept the line hypothesis. Variances are equal. So we conclude that the variance in the resolution time for these batches are equal. So variances are equal means what is the test we have to follow? So where the variances are equal means Fisher's ANOVA is what you follow. Fisher's ANOVA value T is 0.002. Wait. If it is unequal means you have to follow that Wells ANOVA. For that, we have to done the homogeneity test. Homogeneity test for checking the variance levels of different groups, right? So Levin's test, then Barrett's test also we have to check. The value of 0.474, which is associated with p-value of 0.092, it is greater than 2. We failed to get the subsets. So here also it says this homogeneity test, Levin's test and Barrett's test, both are says variances are equal. Okay. So now this variances are equal. We are go with the hypothesis for testing the normality. Next, we are going to do the normality test, whether it is normally distributed or not. Now, the Scarpio-Wilk normality test, which says the p-value is 0.58950. It should be greater than 0.05. And that is, it is greater. That's why we say all the dissolution time for these batches are normally distributed. Okay, normally test is successful. So all the three normality tests, Sharpe-Wilk test, Kolmogorov, Smirnov test, and Anderson-Darling test, everything is greater than 0.05. That's why all are normally distributed. Now we can draw the QQ plot. By using QQ plot also, it's all the lines are in the linear. That's why we are saying it is very close to that line, all the points. That is also we say it is normally distributed. I said we have to follow this Fisher's test of one way because the variances are equal. If it is variances of unequal means you can go with Wells test. Variances of equal means you can go with Fisher's test. Here the p-value is 0.002 or 53. So which is less than 0.05. So as the assumption about the homogeneity of the variance is satisfied, we use the Fisher's ANOVA test. Here this p-value is 0.02, that is, we reject the null hypothesis about the equality of means of 0.011 significance. So we include that the dissolution time for the at least one pair of batches differs significantly. That is, alternative hypothesis will be successful. So they are not equal. So dissolution time for the different groups is vary. That is, differs significantly. So this is one way ANOVA. We can see as a demonstration. Please wait, I'll open JAMOVI.
Sir, Kamal sir, you are not audible, sir.
Okay, sir. Okay, sir. I'm going to start. Just open this existing data set dissolution. Okay, we have two attributes, time and batch. The time is a dependent variable, the batch is an independent variable. A time should be a continuous value. That's why I'm going to edit this data type. It is continuous, it is integer. Okay, I'll just close this. So batch already there we have it's already nominal, it has 3 levels, no need to edit. Okay. So now we have the time and batch everything. Now first we are going to do that analysis of ANOVA, that is one way ANOVA. Before that we have to do that exploration of descriptive statistics. I just move this time variable here and batch is split by both statistics. So it has the mean of different for each group it will display batch 1, batch 2, batch 3 means, median, minimum values and maximum values, everything is plotted. Okay. So now we have to check the Sharpe Wilk of everything of this process. I just click Sharpe Wilk. I've got the p-value of all this means all are normally distributed. How I am saying it is normally distributed? Because p-values of all this all the batches are greater than 0.05. That's why it is normally distributed. Next, we'll go for QQ plots. So all are linear, right? So all the points are near to the line. So that's why we have said it is a normally distributed. Okay. So next we are going to do that. We have the assumption mu0 is mu1 equal to mu2 equal to mu3. We got mu1, mu2, mu3, right? We have our assumption is mu1 equal to mu2 equal to mu3. But in this mean itself, we have decided that are not equal. There is a significant difference between mu1, that is batch 1, batch 2, and batch 3. By this result we can conclude. But by applying the test, only we have to say the stronger conclusion by applying that analysis. So clicking the ANOVA, I can go with one way ANOVA. So I have a time variable, dependent variable, and independent variable, sweeping variable is batch. Now Welch test, that is don't assume equal. That is the what is that? The homogeneity test. After the homogeneity test, we will conclude. We again get the values of Welch test and Fisher test. This is the ANOVA's variance test. So assume equal. If it is equal means what is the value of P? If the variance is not equal, what is the value of P? In the Welch test P value and Fisher's test P value, we can have it is less than 0.05, less than 0.03. So first thing before that, we have to check the homogeneity test. So homogeneity test, it's give these values of P value is 0.696. That is, it represents greater than 0.05. That is, your variances are equal. Okay, if it is equal means you can go with Fisher's test. Okay, you can go with Fisher's test. You want to check the normality test, you can do the normality. So also delivers the normality is 0.590, which is also greater than 0.05. That's normally distributed. Okay. If you want to give the different descriptive table, you can get a group descriptive table of the mean of standard deviation and standard error, everything you can get. The descriptive plots you can got it. This is the plot. You can get through the plot, you can where this ranges appears of each dissolution time of each batch will occur. So from this diagram itself, we can conclude that there is a significant difference between the batches. See, the batch 1 and batch 2 are mostly similar. The batch 3 is totally different. It takes this different dissolution time, 50% different dissolution time. So now, from the homogeneity test, we got what is that? Homogeneity test, we got the value of a funded, but it is we say it is equal, and we can conclude we can go with Fisher's test. That's why we can get the value of Fisher's value 0.03, which is less than 0.05. That is, we have to reject the hypothesis. We have to accept the alternative hypothesis. We concluded there is a significant difference between this, the batches 1, 2, and 3. Okay, this is about this analysis of variance. That is one-way ANOVA. Okay. Similarly, if you have two independent variables, two different variables means you can go with two-way ANOVA. For example, time and in more one of frequencies, anything, any other examples. If you have any frequency, you can just both are different means you can drag and drop the frequency into the different variable. You can perform on this ANOVA as that is two-way ANOVA. That is, you can directly go with ANOVA. You can click with ANOVA. You can go with that is two-way ANOVA. More than one different samples means you can go with two-way ANOVA. If it is non-parametric means you can go with one-way ANOVA, Kruskal valves. Repeated methods of ANOVA, you can go with Friedman ANOVAs. So these are some different analysis of variances. This is one example. Next, we will see this. Next, there is a regression. Regression, which we have correlation matrix, partial correlation, and linear regression. We have to do that. So let's next half an hour we will see this level regression analysis. So single linear regression analysis using JAMOVI. So correlation analysis is used to study the strength of relationship between the two or more quantitative variables. Correlation shows the degree of linear dependence between two variables. The variable, for example, I have to take the variable one as x, the another variable is y. If it is correlated, if these exists a cause and effect relation between them, and the changes in the one variable is accomplished by the changes in the another variable. That is, any changes I have to made on the variable x, it reflects on the y. Okay, that is, it's reflects the correlation analysis nothing but that is it's present the strength of relationship between the two or more variables. Okay, but that is increase or decrease in one variable is accomplished by the increase and decrease in the another variable. Height and weight of the group of people and rainfall and yield of graph. So rainfall is increases, yield of graph will be increases. If it is higher rainfall of increases, the yield of graph is increases, the price will be price and demand will be, that is price is a variable which affects the demand. Demand is a variable which affects the supply. So these are the two quantity variables which may affect cost. Anything in the causes or changes affects in the variable, one variable which will be reflected onto the another variable. So we have two types of correlation: positive correlation and negative correlation, and the other one is zero correlation. So negative correlation is when changes in the two related variables takes place in opposite direction. If it is increase or decrease, once that is it will be one variable is accompanied by the increase means another one is decrease means that is negative correlation. In negative correlation, if the rate of increase or decrease in the two variables is constant, then the correlation is perfect negative. Otherwise, the correlation is partially negative. Example is the price and demand of commodity, sales of woolen garments, and day temperature, volume and pressure of a perfect gas. So zero correlation. If changes in the variable of one variable does not affect the values of the another variable, then it is said there is zero correlation. Positive correlation, when changes increase means it is increase, decrease means decrease. So it is also examples of demand and supply of commodity, income and expenditure. Changes does not reflect to the another variable. That correlation is called as zero correlation. If the two variables are not related by cause and effect, but the variable shows the correlation between them, then such a correlation is called as superiors or nonsense correlations. Okay. Next, we are going to do this regression analysis. What is a regression analysis? It's a method of investigating a relationship between the variables. For example, a real estate agent is to relate this sales price of home based on some characteristics such as a number of bedrooms, total area, the number of bathrooms, regions, etc. The relationship can be expressed in the form of equation or in a model consisting the response variable and one or more explanatory variables. Okay. So if the number of bedrooms is increased means the rate of the whole house will be increased. Okay. The square feet is increased means the price is increased. The total house price will be increased. The square feet of area is lesser reduced means the house pitch will be reduced. Okay, based on that, they have to analyze the price of the total home. Okay, the purpose of regression analysis is to find whether the relationship existing between the variables. Next, to test whether the relationship is significant, to find the mathematical relationship between the variables if exist. To test whether the mathematical relationship is significant, to predict the value of different variable for give values of independent variables. So types of relationship we have deterministic relationship and probabilistic relationship. So no randomness here with randomness. So deterministic relationship is nothing to exactly describe the relationship between the variables. For example, circumferences and diameter. Then Fahrenheit and Celsius, both are dependent. Both are the same values, but the measurement is, the name is different, right? That is deterministics. Probabilistics means, so probabilistic relationship cannot exactly describe the relation between the variables. For example, weight and height, yield of graph and rainfall. Okay. So regression analysis is the differences that there are two different linear regression, non-linear. So simple linear regression, multiple linear regression. Non-linear means simple non-linear, multiple non-linear regression. So linear regression analysis, it has the dependent variable is continuous and the independent variable may be continuous or discrete. So dependent variables is also called as a response or outcome of the variable. Independent variables can be called as predictors or explanatory variables. So simple linear regression and multiple linear regression. Simple linear regression techniques is used to predict the value of continuous variable y based on the one predicted variable x. Next, multiple linear regression techniques is used to predict the value of continuous variable y based on the more than one predicted variable. So predicted variable is one means that is simple linear regression. More than one predicted variable means that is multiple linear regressions. So simple linear regression means the simple model can be stated as so yi equal to beta naught beta 1 into xi plus bin. So I equal to 1 to n. So y is the value of response variable and x is the value of predicted variable and b naught b1 are the parameters regression coefficients. The ei is random errors terms, that is if there's any error which occurs. The simple linear regression model is used to predict the one response variable based on the one predictor variable. Okay, one predictor, based on the predictor, we can find the one response means you can go with single linear regressions. Assumptions for important assumptions for simple linear regressions, we have to find this was the regression model is a linear parameter. So errors are independently distributed, errors are normally distributed, and errors are equal variances. So we have to check all the things like hypothesis testing and ANOVA. Here also we have to check the normality, equality of variance, and independent of variables, linears and parameter, everything you have to check. So this is that linearity check for that normality test we have to define the graph. Okay. For example, single linear regression analysis, let us consider the data sets available in the R. The car dataset contains information about the speed of cars and the stopping distances. So this is, we have to open this JAMOVI screen and open the dataset car. It has that car at a speed, car speed and the distance within the car, the number of cars, the car numbers, it shows the datasets. So delete the car, no need to, that is speed and distance only maintained. Next, we have to select the variable and edit the variable. Speed is a continuous variable, right? Distance is also a continuous variable. So both are continuous variable. Descriptive statistics for both variables you have to find it. What is the mean, median, everything you have to find for speed and distances. Next, you have to select the histogram. So this is the histogram diagram of the field and distance variable histogram. Then box plot, that is upper quartile, lower quartile, intermediate quartile, Q1, Q2, Q3 plot you have to calculate for the both variable, density and speed versus density. Then we have to plot that linear regression line. So what is the linear regression line means? We can go with analysis, regression, linear, single linear regression. Click on regression line as linear and select the x-axis. Speed is to be in x-axis, distance is to be in y-axis. You have to select. Then scattered plot with density. You can go on to density. You can go with the density will be this is the density of distance for the height. So for the distance for the speed. Then scattered plot with the standard error. We can got any errors if it is that is EI, the variable EI, that is standard error. This is the space that's the shades represents the errors in this data sets. Now we have to define the correlation matrix. So analysis menu, we can click on the regression option, select correlation matrix. The correlation matrix, we'll click on the correlation matrix. We have to go with Pearson's correlation matrix, Spearman correlation matrix, then Gardner's Tabu correlation matrix. We want to need this correlation matrix. You just click on the ticks, you can get the correlation matrix on this regression. The correlation matrix, the additional options are there, that is report significance, flag significant correlation, the number of n number of what is the number of occurrences, then confidence intervals we have to calculate. The correlation matrix plot also we have to click on the correlation matrix plot. The plot will be displayed on the screen in the right side corner. Analysis menu, regression option and linear regression. Click on the analysis. You can go with linear regression. You just drag and drop the variable speed and distance. Then you have to correlate. You can drag the distance in the different variables. Speed is a covariance. Then it will generate the value of speed for this p-value, which is should be less than 0.01. Based on that, we have to test. So omnibus ANOVA test for the significant of model. You can click on the omnibus test, that is ANOVA test. That is the name of the omnibus test, that is ANOVA test. You can click on that, you'll get the values. From this value, we can do that. Then assumption checks, we have to check the normality. So whether it is either the data set is normally distributed or not, we have to check. The multiple linear regression, that is a single linear regression. Multiple linear means the predictor is more than one predictor. The independent variable is only one independent variable. Okay, examples of regressions are load the data trees from the data sets package, display the structure of trees in the data sets, and check the dimension of the tree data sets, obtain the summary statistics for the trees data sets. So these are some examples. Height and volume, weight, girth. These are the three variables. Two height and volumes are predictor, girth is an independent variable. So there is a trees data set. It has girth, height, and volume. It has ID also. So these are the variables are girth, height, and volume. So we can calculate the mean, median, mode of the descriptive statistics. Then we have to go with correlation matrix, the Pearson correlation matrix displays these values. Then plot all this hypothesis, correlated or not correlated. Then we have to define this, do the correlation analysis for linear regression, volume, and girth. Then we will get the value of P, everything. Based on the P, we will accept the hypothesis or not the hypothesis. If it is less than 0.05, that is not correlated. Greater than 0.05 means there is a relationship between the two variables that is correlated. So similarly, we can do the linear regression of volume and height, and width and height and volume. So we will do that test the fit measures and overall model test. So model specific values we can do that. So for this linear regression, the FR measures for this omnibus test, here for that is multiple linear regression, we have to go with R squared. So these are the tests we have to get the values. So this is that multiple linear regressions. So this is all about linear regression and multiple linear regressions. So based on this, the statistical problems, we can give the solutions through this a JAMOVI with statistical computing analysis. So before we are doing the analysis, we must know the basic statistical concepts, and that concepts of analysis, analysis of variance, and descriptive statistics, and exploratory data analysis, and what is the hypothesis testing. We should thorough about this. And then what is the type of the test for the type of the problem? What is the type of the variable? What is the type of that standard tendency value? Based on that, we can decide the test and do the test, and we can give the solutions. So always for all the given problems, we have followed the 5 steps. First, you have to pick the null hypothesis, then alternative hypothesis, check for the normality, then do the analysis test. Here only we have to decide the test. Which test we are going to be applied. That is t-test, and then you find the p-value. Based on the p-value, we can define this p-value is equal to 0.05. This greater than 0.05 means only we have to accept this null hypothesis. Otherwise, we have to fail to accept this, reject the hypothesis, null hypothesis. So this is assumptional test. Then regression, linear regression. So these are that we can do on JAMOVI. And then one more thing, we have the frequencies and the independent samples, paired samples. We can go with factors, reliability analysis. If you want to install any model, you can click on this plus, you can do that model. Then you can predict any problems, and you can do, give us a solution as a data scientist, or as a research scholars, researchers, and data analyst, like anything you can do. It is the simple software. It is alternative to the SaaS. It is available in the internet. You can download and you make use of it. So we will conclude this session by this regression analysis. If you have any queries, please ask.
Thank you, sir. Dear participant, please raise your hands or unmute your or post your questions in chat box. Thank you, sir. First of all, I would like to thank our founder and chancellor, A.C. Shanmugam, sir, and our honorable president, Engineer H.S. Arun Kumar, sir, for giving this golden opportunity to conduct this 5-day FDPs. It gives an immense pleasure to thank our vice chancellor, Professor Dr. S. Geeta Lakshmi, ma'am, provost, Professor Dr. G. Gopalakrishnan, sir, registrar, Professor Dr. C.B. Palanivel, sir, for the wonderful support for this event. I express my heartfelt thanks to our director, Academic Staff College, Monali Pandey, ma'am, for his support and guidance. We would like to thank our beloved Dean, Academic Staff College, Dr. Gomadi ma'am, for the continuous support and encouragement to make this even more memorable one. I would like to express my gratitude towards Kameshwaran sir for accepting our invitation and spending her valuable time and knowledge with us. Last but not the least, my special thanks to the organizing committee and the participants. Once again, I thank one and all. Thank you, sir.
Thank you, sir. Thank you so much, sir.
Thank you so much, sir. Thank you, sir. Thank you so much, sir. Participants, feedback link has been posted in the chat box. Dear participants, now feedback link has been posted in the chat box. Kindly submit your feedback by 4:15 p.m. Now we can